Welcome to this video about tests about a difference in means. By the end of this video, you should be able to perform a significance test about the difference between two means using the four-step process. Alright, so we're kind of going back a little bit to the memory strategy scenario that we had in the previous unit. This time, I'm going to take a sample of 32 seniors, and they were randomly selected to try both memory strategies. Each student calculated the difference in the number of words, strategy 2 minus strategy 1. The mean of the differences was 1.5 words, and the standard deviation of the differences was 2.7 words. Do these data give convincing evidence that strategy 2 improves memory at the alpha 0.05 significance level? Now, I want to point out this is a single sample of 32 students. This is not two independent random samples. This means we're dealing with a mean difference, not a difference of means. Okay? Remember, a difference of means involves two independent random samples. So I'm going to get you started. You're going to finish this out on your own and come back and check to see how you did. So what is our parameter here? So we're going to say mu1 minus mu2, and that is the true mean difference in word recall. True mean difference in word recall. And they told us the order to do this. But we're still going to write it here. It is strategy 2 minus strategy 1. Okay. Our statistic, they told us what it is, so I'm going to write our mean difference is 1.5. They told us to use the alpha 0.05. And our hypotheses, we assume there is no difference. So our null is 0. And our alternative, well, let's think about that. We're saying strategy 2 improves memory. If we're subtracting strategy 2 minus strategy 1, that means our difference has to be greater than 0 to make that happen. Alright, I want you to go ahead and complete the rest of this. Come on back and let's see how you did. Alright, so the name of our procedure is a one sample t-test for the mean difference. It's one sample because it was a single sample of 32 seniors. Okay, for our conditions, it was a random sample of 32 seniors. We always check that so we can generalize to our population. For our 10%, 32 is less than 1/10 of all seniors, and we do that so the sampling without replacement is okay. So we're able to use our standard deviation formula that we have, otherwise we'd have to use a different one. And then normal, we were lucky, our sample size is bigger than 30, so we were able to invoke CLT, meaning the sampling distribution of the mean difference is approximately normal. Okay, so when we come down to the do part, when we plug everything in, we had our mean difference of 1.5 minus our null value of 0 divided by the standard error, gave a calculation, a t-statistic of 3.14. When I put this into the calculator, so I'm going to remind you what that looks like. Go into stat, over to test, t-test. Our mean was 0. Our statistic was 1.5. The standard deviation was 2.7. We had 32. Our alternate was greater than. And we're going to calculate it. And so I got the 0.0018. That's by the calculator. You could have also looked it up on your table of values. Another thing I want to show you here is if we go into that t-test, all of our information is here. Right there it says draw. I can have it draw my distributions too. Give it a second. Here it comes. It's a little late to see. And then it will shade And it shades ever so slightly out here. It's really kind of hard to see. It's kind of a nice thing to have a verification of where your shading should go. And so with our p-value of 0.0018, assuming our null is true, that there is no difference, there is a 0.0018 probability of getting a mean difference of 1.5 words or more purely by chance. Because 0.0018 is less than 0.05, we will reject the null. We do have convincing evidence strategy 2 improves memory. All right. So hopefully we're kind of getting this down or understanding the difference between the difference of means and the mean difference. Okay, and that's going to be part of what our summary is about. So let's go ahead and flip this over and let's do a quick summary here. All right, so we have two things that I want to tell you. That is probably more than enough room. First part is one sample t-test for mu diff. Remember, your formula is your mean minus this will be your null hypothesis right there, which should be 0. And then your standard error, which is the standard deviation of the sample divided by the square root of the sample size. And I want you to use the t-test on the calculator if you're not going to use the table B. But if you're going to do that, you must set everything up. Everything still must be plugged in. You must show all your work. The reader has to know that you know what you're doing. Okay? And then the next part, this is just to really hopefully delineate just a little bit further for you between the two tests. So the paired T, which is the mu diff, that's the difference in means. When you have a difference in mean, you have one sample and the data are paired. So one sample and the data are paired. Usually you'll see it either like this memory training where it is, we had the people and they did this and then they did this and they checked the difference between them. You just have one sample of something and two different things are being done to it, essentially is what's happening. You're looking at the mean difference. That's the mu diff. And what we do is we subtract the groups. Then we average. So we're averaging the results of the subtraction. For a two sample T, you have two independent random samples. Okay. It's a difference of means. Which means we're taking mu1 minus mu2. And in this, you find the averages separately, then you subtract. You have two groups, you find the group's averages, then you subtract them. Okay, so what you're going to do for the check your understanding is I have 3 scenarios here. Read through them, determine whether they're a paired T or a two sample T. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.